Hello, welcome back to Chapter 8, Section 6, Radical Expressions and Rational Exponents. In these first two problems, we're going to just talk about the vocabulary. We're going to find cube, fourth, and cube roots. Square roots, fifth roots, etc. could also be part of the problems. So what this is asking is this. What number multiplied by itself, 1, 2, 3, is going to give me positive 27. You can think of this as what number to the third power equals 27. So if I knew what that was, say 7 to the third power would be cubing it. Excuse me. But since I'm going back, what is under the exponent is my unknown. I'm going the other direction, so I'm finding the cube root. And you can try different things. Eventually you're going to end up with 3 times 3 times 3 equals 27. 3 to the third power equals 27. So the cube root of 27 is 3. And I want to point this out again. I'm asking for what number multiplied by itself equals 27. So I'm looking for just that number, okay? I mean, these are all the same. I get that, but don't write 3 times 3 times 3. All right? That kind of defeats the purpose. I'm asking for what number goes in that box. It's the same number that goes in that box and the same number that goes in that box. What number goes in each of these boxes? 3. But I don't want the whole thing. I don't want 3 times 3 times 3. And even me saying that out loud, I probably confused people, but that's one of the things that, well, it's one of the questions that a lot of people ask. So ignore that I just said that if that's more confusing than helpful. The fourth root of 625, same idea. What number times itself again equals 625? So what number goes in that box? And it'll be the same as that, and that. Okay, so it's not going to be 1, it's not going to be 2, it's not going to be 3. You can try 4. You eventually end up with 5. So the fourth root of 625 is 5, because 5 to the fourth power equals 625. And for these, again, like you're probably wondering, well, how'd you get that in your head so fast? You really should, and it's on Schoology, it's in there, you really should have a list of your powers of 2, your powers of 3, and your powers of 5. Powers of 4 you can probably come up with if you needed it. Maybe powers of 6 and powers of 7, maybe, but I don't think it's going to get too crazy. All right? And if it's not one of the lists that we have, then you can figure it out. The cube root of 0. Okay, this one, obviously it's 0. But I'm a little weird about the obviously. Because 0 multiplied by any number equals 0. So then you can say, well, what if I put 0 here, but I put any other numbers here? Now, some of you have already caught the fallacy in my explanation, which is why I'm talking about it. The key to this is that all of these have to be the same. Okay, just like 3 times 3 times 3, they were all 3s. This one was 5 times 5 times 5 times 5, they were all 5s. So I know the only way to multiply and get 0 is if one of them was 0. And since I'm finding roots, that means that all of them have to be 0. So the cube root of 0 is 0. So I think the thing is that I've had students question that before, and it's like, well, they all have to be the same. Did you miss that? But I think that the issue is because when we solve quadratic equations, I've got 2 expressions that multiply to give 0 if I solve by factoring, and I get 2 different numbers. When one's 0, the other's a different number, and vice versa. So I think that there's some follower from that, but in that case we're talking about something completely different. Okay, we'll see you in the next video.